Hello friends, in this video I am going to explain you another sort of deletion which we encounter in the AVL search tree, that is a deletion which warrants a rotation which is called the R1 rotation. That is, we have described the R0 rotation in one of our previous videos. In this video I am going to show you how the deletion takes place, where we need to perform the necessary operation which is called the R1 rotation, and how that R1 rotation can be performed I will just show it to you by means of an example. So I will just write an AVL search tree, will draw an AVL search tree and show you how the R1 rotation takes place. So let me just draw an AVL search tree like this: 37, 26, 18 and then 16. And to the right of 26 is 28, and to the right of 37 is 41, and to the left of 41 is 39. So we have taken this example. So we see that the balance factor of this one is 0, the balance factor of this one is 1 minus 0 is 1. The balance factor of this one is 2 minus 1 is 1 as well. The balance factor of this is a leaf node. Since it is a leaf node, the balance factor is 0. It is also a leaf node. The balance factor is 0. And the balance factor of this 41 is 1 because it is 1 minus 0. The balance factor of 37 is 3 minus 2, that is 1. So all the balance factors are lying within the permissible range of values for an AVL search tree. So if we delete suppose this 39, if we go on to delete this 39 from over here, delete 39, then what will be the situation which needs to be, which warrants the R1 rotation to be performed? I will just show it to you. So this 39, after deletion of this 39, the tree will look like this: 37, then 26, then 18, then 16, then 28, then 41. So this 41 and this 39 has been deleted. So we'll just consider this 39 to be like this. Sorry, 39. So 39 has already been deleted, but we will consider the 39. If 39 would have been here, the situation would look like this, but the 39 is not present over here. We will need to recalculate the this balance factors yet again. So the balance factors of 16 will be 0, 18 will be 1. It will not be affected by the deletion process of deletion of 39. The balance factor of this 26 will remain as 1. The balance factor of 28 will remain as 0. The balance factor of 41 it was 1 previously. Now the balance factor of 41 will be now 0 because 39 is not over here. And the balance factor of this 37, let me see this. What is the balance factor of this 37? It was originally 1, but now the balance factor is 3 minus 1 because 39 is not present. The height of the right subtree is only 1. The height of the left subtree is 3. So 3 minus 1 gives us a value of 2. So 2 is a balance factor which is not lying within the possible range, permissible range of the values. So now we see that in the backtracking process we'll see the deleted node. From the deleted node we'll start our journey to the root node and see in which node we first encounter the situation where the balance factor gets affected by the deletion process. So if we start from here, this is not at all present. We will start from here rather. So this 41 has a balance factor of 0 which lies within the permissible range. We go to this one and see that the balance factor is 2. So we get the violation of the balance factor over here for the first instance. In the first instance, so this will be taken to be the node A, and with respect to node A, we are seeing that this 39 is a part of the right subtree of node A. So the deletion process will be an R process, that is a right deletion. The rotation process will be a right rotation because this 39 was on the right subtree part of this 37, that is the node A, and the left subtree starts from, with respect to node A, the left subtree starts from 26, and this 26 is to be considered as the node B. So B has a balance factor of 1, so the rotation will be named as R1 rotation. So the rotation is R1 rotation. And what is R1 rotation? How it is performed? We'll just do the same, follow the same principle, the same type of procedure which we followed in the case of R0 rotation, if you recollect, that we were doing some sort of situation which was quite similar to the LL rotation. That is, we are going to pull this node from this side in a clockwise manner, so as to make this 26 come over here, and 37 will be the right subtree, will be the right child of 26, and in this way we will also perform the R1 rotation as we have performed in the R0 rotation. So after performing the R1 rotation, we will see that this 26 is pulled from this left side, and 26 will come over here, 37 will come over here, and this 41 will come over here. There is no 39 because 39 was not at all present in this figure. We will not write a bit of 39 over here at all, and this 26 has a left child in a node which contains the data value 18, and it has a left child in 16. So, and one thing which needs to be accommodated is the node which is 28. See this 28? The 28 is a node which is present on the right subtree of 26, and it was present as the right child of 26. But now the right child of 26 is 37. So the right child of 26 is now 37 by the process of this rotation. And so what we will do in order to accommodate this 28 on the right subtree, because it should be a part of the right subtree of 26, because it is greater, the value 28, the value 28 is greater than 26, so it should be accommodated on the right subtree of 26. So since the right child has now become 37, 28 will now not remain as the right child, it will be accommodated on the right subtree in this manner, so that this 28 comes to be linked to this 37 as the left child of 37 and be present over here, so that this 28 is perfectly on the right subtree of the node 26. So now in this process, have we left over any node? Let me see. 1, 2, 3, 4, 7. 1, 2, 3, 4, 5, 6. 7 is not there. 1, 2, 3, 4, 5, 6. So we have 6 nodes. So it's okay. So now we are going to calculate the balance factors. So this is a leaf node, the balance factor is 0. This is a leaf node, the balance factor is 0. This is a leaf node, the balance factor is 0. This is a node which has a balance factor of 1 minus 0, that is 1. This has a balance factor of 1 minus 1, that is 0. This has a balance factor of 2 minus 2, that is 2 minus 2 means 0. So we see that all the balance factors, of all the nodes of this tree is lying within the permissible range of values for an AVL search tree, and this is a complete AVL search tree where the balance factors are all lying within the permissible range of values, that is within the -1, 0 and 1 values. So it is an AVL search tree, perfectly an AVL search tree. So after the R1 rotation has been performed, we have retained the properties of the AVL search tree, and after the deletion of this 39, we have performed this R1 rotation in order to balance the tree in such a way so as the tree doesn't cease to become an AVL search tree. So it remains as an AVL search tree now, and this is the solution to the deletion of 39, and for that we have performed the R1 rotation. So this is the question, this is the intermediate step, and this is the final step, and this is the answer. So if you have any doubts and queries in this example, if you can well post your doubts and queries into the comment section below so that I can address them. Thanks for watching this video.